Okay, so in this video we're going to find the Taylor series approximation for e to the x over 2 centred at 0. Now, Taylor series is an approximation with a formula which looks something like this. So f of x, that's our f of x, that's what we're trying to approximate, equals f of a plus f prime of a x minus a over 1 factorial plus f double prime of a x minus a now squared over 2 factorial plus f triple prime of a x minus a cubed 3 factorial. Just keep going on and on and on. So just to explain what all these are, so a, that's the value where we're going to centre our approximation at. So in this question it's at 0. So we've got a equals 0. So now all these terms, x minus zeros, they could just cancel out now, just become x cubed, x squared, x. Okay, and now these f's are all evaluated for our function now. So when we take the first derivative, for example, we take the derivative of e to the x squared, the x over 2, not x squared, x over 2, and plug in that value there as a number. So these will all give us our values. And then these are all the factorials. So 1, 2, 3, keeps going on, 4, and so on and so on. Okay, so as we're centering at 0, we can just simplify this up at the moment, because we're going to just work it at 0. So f of x equals f of a plus f prime of a x over 1 factorial plus f double prime of a. So that's 2, that's also a 2. Same notation, I'm just trying to show you both different ways of writing it. X squared 2 factorial plus f3, that's triple prime, so that's the third derivative of a x cubed over 3 factorial, so on and so on. Okay, now there is a shortcut to working out this Taylor series here. Instead of taking derivatives of all this and plugging it all in and doing all those calculations, we can save a lot of time in it. So we know a Taylor series, which is a standard Taylor series, very similar to this, and that's e to the x, which equals 1 plus x squared over 2 plus x cubed over 3, da, 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 da. And this is also centred at 0, which is very important, because that's centred at 0, ours is centred at 0. If this was centred at 1, wouldn't be any use to us. We just have to mess around with it a little bit and be a little bit messy. So as this is centred at 0, what we can do now, we can substitute x for x over 2. So that gives us now f of x, that's our f of x. So wherever we see an x in this Taylor series, we just substitute x over 2. So 1, there's no x in that, so that stays. X is here, so we just substitute x over 2. X squared over 2. So now a little bit more tricky how we write this. So for x squared, we want x over 2 squared. That would be in the numerator. And then over 2. Sorry, that should be 3 factorial. That's 2 factorial plus x cubed. So x over 2 cubed over 3 factorial, so on and so on. Always important to write the dots here for so on and so on, because this could go on forever and ever and ever. And the more evaluations you do for each x, all the terms, the closer you get to the real value. Okay, so let's simplify this up a little bit. So 1 stays the same, x over 2 stays the same. Right, x over 2 squared. So that becomes x squared over 4 divided by 2 factorial, which is 2. This one, x cubed over 8. So basically when we're doing, oh, let's just write that a little bit better. So when we're doing x over 2 cubed, we're just writing basically x cubed over 2 cubed. That's the same thing. So x cubed over 8 divided by 3 factorial, which is 6. Dot, dot, dot. And now we can just simplify these all up. 1 plus x over 2, that's fine. X squared divided by 4 divided by 2 becomes x squared over 8. And then x cubed over 8 divided by 6, that just becomes x cubed over 48. So on and so on and so on. And then that is our answer. And that's a lot quicker than having to work out all the derivatives. So there we go.